be telling you a little bit about the Spock, which is the computer that is used on board. Okay, after they talk about that, I'm going to be talking about the seats and how people are seated during takeoff. And I'll be pointing to the two seats or the positions on the floor. Then I'm going to be going to the aft flight deck and show how it can be flown from the back, pointing to the payload bay windows, the overhead windows, how you can see out, and the mission-specific panels that are going to be behind me. I'm going to be standing right here because Dick's going to be in this seat, and Mike is going to be kind of balanced to his right with the Spock on his lap. He's going to pull the Spock out, and he's going to be over here. Okay, at that point, Mike's going to move out of the way, and I'm going to be going downstairs. Okay?
Okay, you ready to come down?
All right, now when I go downstairs, that's going to move.
I'm going to switch the cameras.
Okay, and I'm going to pick up the handheld mic down here. Now, the camera that is right over here should pick me up coming down. We're going to talk about the bathroom first? Is that what we decided? Oh, the handheld mic. Okay. Yeah, I wish I had my... Ron's going to be standing right here, okay? All right. So, can I just talk and... Okay. Once I get down to the mid-deck, I'll be talking about the WCS. Can you see the WCS?
Yes.
Okay.
Yes, I can see it.
All right. So on the first part, after I push the privacy curtain away, I'm going to be standing over here by the WCS, talking to that camera, explaining how this is configured, talking about the towels and the washcloth. And I'll be talking about the seat. The other person is going to be sitting right in front of the WCS for takeoff and re-entry. And then I'll talk about the sleep bag. Now, at this point, as I'm talking about the sleep bag, hopefully this camera is going to be ready. Okay, and that's why we put the sleep bag in, because we didn't know whether they'd have enough time if all I talked about was the WCS. So we thought I could talk about the sleep restraint and maybe, mention the hatch, but then turn to Ron at the galley, and he would be taking a container out, and I'd be explaining that this is how we rehydrate the food. And he will do the container for me since I have the handheld mic.
He'll do it right.
Okay. Okay, yeah, showing how the drink container works, and then he'll put that back on. Okay? At that point, he's going to... Well, I think we left it open. He's going to open up one of the lockers. And it's just going to be a clothing locker, and it's going to have the restraints here, so I can explain to the kids that everything has to be held down, because otherwise we'd have a problem with things floating away. Okay? Then he's going to put that back in the locker, and while he's putting it back, I'm going to be talking about the treadmill that's going to be here. Now, as I'm talking about the treadmill, this is the cue for the crew to start floating into view.
That was one of the field trips that had planned, one of two that had planned to be live. So again, my name is Barbie Buckner, and I'm coming to you today to talk about the lost lessons of Christa McAuliffe. And in particular, we're going to look specifically at her Effervescence activity. There's a video that talks about the Teacher in Space program. So if you're not familiar with the Teacher in Space program, or how the process came about that they selected Teacher Christa McAuliffe, this will give you a little bit of background about that.
Communicating the space experience, sending someone into Earth orbit who can tell us what it's like in our own terms, has long been a NASA goal. And in August 1984, the Spaceflight Participant Program was given the green light by President Reagan.
Today I'm directing NASA to begin a search in all of our elementary and secondary schools, and to choose as the first citizen passenger in the history of our space program one of America's finest, a teacher.
Last June, the semifinalists in NASA's Teacher in Space project met the press for the first time in Washington, D.C. The 114 educators, selected from over 11,000 applicants, spent a week in the nation's capital, becoming familiar with the history of space travel, and of course, taking notes in workshops dealing with various aspects of shuttle flight.
Go get it red hot.
The next major milestone came in early July, when the 10 finalists were announced. These teachers had survived an extensive screening process, but they had to demonstrate even more right stuff during their 2-week stay at the Johnson Space Center in Houston, Texas. After a series of tests to ensure that they were medically fit to fly aboard the shuttle, the 10 were given a ride on the KC-135, a hollowed-out padded jet that simulates weightlessness for short periods of time. Finally, on July 19th, Vice President Bush made the historic announcement.
Congratulations.
And we have a elementary school teacher from McCall, Idaho, was selected as the backup candidate, and Christa McAuliffe, a Concord, New Hampshire high school social studies teacher, will be the one to actually fly in space early next year.
It's not often that a teacher is at a loss for words. I know my students wouldn't think so. I've made 9 wonderful friends over the last 2 weeks. And when that shuttle goes, they might be one body. But there's going to be 10 souls that I'm taking with me. Thank you.
You can see everything from
Since their selection, your training in Houston. There's been a lot to learn, but they've shown that good teachers make excellent students. During her shuttle flight, in addition to keeping a journal, Mrs. McAuliffe will teach 2 live lessons from space. One called The Ultimate Field Trip, and the other, Where We've Been, Where We're Going, Why, which will be broadcast via satellite to schools around the country. She will also do a number of other experiments that will be filmed for classroom use after the mission is complete. Her goal?
I would like to humanize the space age by giving a perspective from a non-astronaut, because I think the students will look at that and say, this is an ordinary person. This ordinary person is contributing to history, and if they can make that connection, then they're going to get excited about history, they're going to get excited about the future, they're going to get excited about space.
While Christa prepares for her flight, life goes on in Concord, New Hampshire, where she has taught for the past 5 years. Understandably, things at the McAuliffe house have changed. For example, there's now a noticeable path from the freezer to the microwave. But husband Stephen, in return, daughter Caroline, and son Scott have taken on their added responsibilities without reservations.
You know, you're talking about a human being being free of the bounds of gravity, orbiting the Earth. There aren't many human beings that have done that. So I think both of us feel that whatever the price in terms of readjustments or my taking on things that I probably should have been doing before anyway and hadn't done, whatever those prices are, they certainly pale in comparison to the opportunity.
Visit Concord High, and you immediately understand what a special teacher Mrs. McAuliffe is. Former student Andy Clark.
Even though Mrs. McAuliffe was a great economics teacher, I think what I learned most from her was outside the classroom. She taught me that the little person counts and that anyone can make an effect on our society and on the world. She proved that by being the first private citizen in space and being the first teacher in space. And I think she's a tribute to her profession, and we're all very proud of her.
Even amidst the excitement of witnessing she doesn't forget her students.
I mean, the whole thing is so gorgeous. You just want to bring it all back into the classroom for the kids.
I love that last sentence. You know, you just want to bring it back to the classroom to the kids, and that truly was what Christa was all about. So the Teacher in Space program was announced by Ronald Reagan. It was to send the first private citizen into space, and President Reagan at that time thought of all citizens across the U.S. The citizen that should go should be a teacher. What an honor. And it is called the Teacher in Space program. It ran from 1984 to 1990. The goal was to spur student interest in mathematics, science, and space exploration. The teachers did 5 months worth of training, so it was a condensed training, not like what, I don't want to say a real astronaut, because they were training them to be real astronauts, but they were condensed the training into 5 months, whereas a regular astronaut would be like 2 years to go on a shuttle launch. And then they were expected to then return to the classroom and teach from that. There were 10 teachers out of 11,416 applicants, and they narrowed those down to 10 teachers that went to Johnson Space Center and received further training. And this picture that's here, you can see then Vice President Bush making the announcement, and that's Christa there in the yellow, and a few of, but not all of the other 10 there around her. And in Christa's application, she wrote, "I want to demystify NASA and space flight." Adding that she wanted to keep a diary to humanize her experience because she wanted students to see and understand the special perspective of space and be able to relate it to them. Vice President Bush announced that Christa was the finalist, and the runner-up was Barbara Morgan. And in that inset picture there is a picture of Christa and Barbara. And Barbara as Christa's backup. The two of them continued on with the 5 months worth of training. This is Christa in Micro G on one of the Micro G flights. And one of her quotes, "Reach for it, push yourself as far as you can." And I think that just describes her on so many different ways. Dr. Janice, so much about Christa, changed so many lives. So here's more photos of the 0G on the left. You've got the leapfrog on the right. They're actually injecting a hydroponic solution into a chamber. And that's, again, while they're in 0G. So on the 0G flights. And then here, just more training photos. I just tried to capture some of the amazing photos that were available of the Challenger crew. One of the things that, I find so amazing about NASA is, you can get amazing shots of launch or whenever they're on flight, but they also take those same kinds of pictures with doing the trainings and so forth. There were all sorts of filmed activities and demonstrations. They were practiced on Earth before they ever flew into space. As part of the filmed activities, there were 6 lost lessons. In addition to that, there were 2 live lessons that were to be televised on PBS. I showed you one of those at the beginning, and here I'm going to show you the other one. And this one is titled "Where We've Been and Where We're Going." This one's 3 minutes and 47 minutes long, and we're going to watch it. So
now, Judy, can you zoom out until you can get me in the picture? And then hold it? It'd be nice
So the
to
widest
end
frame,
with the space
Christa,
station.
the widest frame should be from the edge of the lockers to the galley. In other words, you weren't going to try and frame just the blackboard. It's all right if we frame outside the backdrop and get some of the lockers and stuff. You just need the backdrop for
contrast, so that you can see things. And what we were planning on doing, and I don't even know whether, we're assuming that it's going to work. When I show the pictures, we were planning on doing this and having me move rather than have you try to zoom in and out.
Okay.
Because, see, the space station's big enough, and I want some space to be able to do a couple things with it. And the modules that are going to be used for experiments, and the waste module, or the one that's going to be taken off, and how the shuttle links up to it. So as I'm putting it together, and then I wanted to be able to let it go, and show how it's going to look in space, because I think it's hard for kids to realize that you can build something that's not attached to anything. But in zero gravity, you can do that, or, in space, you can do that. So at that point, I wanted to be able to let it go. And since I'm talking about why we're in space and why it's important that other people get a chance to fly in space because of companies and experiments, it would be natural to use him.
Terrific.
Okay. Judy and Ellison and Ron and Dick, of course, the Tidris and the Spartan have already been launched, and the Spartan's already been retrieved. And I'm going to be talking about those. But Barbara's going to be spending some time, and we're hoping that she gets an opportunity to spend some time on Mission Watch and go into more detail, because I only have 15 minutes to do that.
Challenger Houston, we have good video. We're ready for your lesson. Go ahead, Christa.
Okay, we've come a long way from the Wright brothers plane to the shuttle. All right, now, when I've got the shuttle in my hand, that's when I'll start talking about, I probably will talk about the payload bay, and talk about the satellites that are deployed, and then talk about what can be done on board inside the shuttle. I'm going to be mentioning the student experiments that are going to be down here to my right, and I'm not going to be showing them, but I'll mention that there are 3 student experiments on board, because all of them have been put back on board, and I think it might be fun for the kids to know about the chicks in space, because they can certainly relate a lot better perhaps to eggs than they can to the other 2 experiments. All right, so I'll be doing the liquid, marshmallows, otherwise known as cotton balls, and beans. And those things don't even have to be brought that close. I think they'll be able to see that. Okay?
Are you going to mention that the kids can be doing this in their room right now or something like that?
Well, I don't want to mention that, because if I do that, they'll probably be in an auditorium or something. The teachers can do that afterwards if they want to. Whoops. Oh, the zero-gravity environment is just awful. Okay. And then I'll be showing how fluids look before I do the micron beads.
I love how she talks about that that zero-G gravity is just horrible, or that, natural gravity is just horrible. Anyway, cute little joke. Again, just a couple of the examples of the videos that they had planned on making for the students. My, what we missed. And truly what an inspiration she still is today. As a national NASA education specialist, the 6 plans activities, which have now been known as the 6 lost lessons, through a partnership with NASA, STEM on Station, Challenger Center, as well as 2 educator astronauts, Ricky Arnold and Joe Acaba, they have now demonstrated those lessons on the space station, and we have those with you to share today. Here again is another picture of the Challenger crew in zero-G training with Christa. Just the excitement and adventure on her face. I mean, just wow. Using these activities, again, today we're going to talk about the Effervescence ones. Teachers can replicate what Christa was not able to share from orbit, and teachers can still be able to share Christa's wonderful teaching gift and spirit as they are captured in the videos and in her remarks and actions and training, and accomplish most of her lesson plans. And those of you today will truly be able to carry on the legacy and spirit of Christa as you share these lessons with your students. This photo was a pre-flight lesson designed for teachers to use in the classroom to prepare their students for live lessons. And students who experience the lost lessons will truly be the future that is touched by Christa's gift. And while we lost not just Christa, but all 7 amazing astronauts on that fateful day of January 28th of 1986, we still wish to hone their efforts and memories of inspiring students. And a lot of that is done through the Challenger Center. And we will take a look at the Challenger Center after I talk about this lesson. There are, the lesson for Effervescence focuses on grades 5 through 8. However, it can be modified for other ages. How would I explain about her death and then be excited about? Yeah, Lynn, I don't know that. I think the aspect of Christa is more inspirational for the educators than for the students. I don't know that I would go into about her death, especially with 8-year-olds, but just talk about the inspiration that people can be, and that you can make a difference with people that you've never even met. And so, we'll never meet Christa, but the impact that she's made on our lives. So, and And yeah, I'll bring in the Challenger Learning Center and part of her legacy with that in a few minutes as well. So with the effervescence activity, the objective is to show how effervescence happens in space. No, Lynn, you have to do with what fits in your classroom. I had another friend of mine was talking about this, and she's just like, you need to be careful when you're talking with your students about this. I don't, unless the students have a history of Christa, I don't know that that would necessarily really fit. Unless, if they're older. I mean, high school students, yeah, I think you could talk about that and you could talk about legacy. But I mean, at this point, we don't even have the space shuttle that flies. And so because of that, how do you even talk about the shuttle missions whenever you don't have a shuttle anymore? So, but anyway, so back to microgravity and effervescence. We study how bubbles formed and are affected by the size of the antacid and shaking of a bottle. And so with that, these align to next-gen standards. That's part of what Ricky and Joe did, was align them to next-gen standards. There are some key vocabulary and background, and while I'm giving those to you up front, I don't know that I would give those to the students up front. I might use that as a review. Materials that you will need to do this with your students are antacid tablets, water. They typically use 4 ounce per container unless they specify otherwise. Clear containers with lids, timer, measuring cup, and a knife to cut the antacid tablets. So if you had a straight edge, that would work too. So you'll have 4 containers with equal amounts of water. Again, they prefer that to be 4 ounces. 2 are with caps, 2 are without. And so you'll notice that there's lids here, and there are not lids over here. So you do 1 full antacid tablet without a lid, a half without a lid, an antacid tablet with a lid, and then half with a lid. So those are your 4 advanced preparations. And then you would have a timer to be able to note the reaction rates of each situation. And I would recommend that you went ahead and had the tablets pre-cut for you and or your students, just to make life easier. For the opening demonstration, you would hold the antacid up and show it to your classroom. Ask what they think will happen when you drop it into a cup of water, and ask them what they think the tablet's composed of. Explain that you're going to learn about something called effervescence, and then you've got some discussion questions to go with that. How do they think water behaves in microgravity? Do you think a can of soda would fizz the same way in microgravity as it does on Earth? And if you opened a can of soda or something else that fizzes in microgravity, where would you expect the bubbles to go? And how do you think they would behave? There is a phenomenal set of worksheets. And on page 6, this one over here on the right, is designed so that the students can actually take notes while they watch the video of Ricky Arnold. And speaking of that video and Ricky Arnold, we're going to show you that video now, just like we would for the students in class. Here is the video of Ricky Arnold doing the demonstration about effervescence, and the link to the YouTube is in the chat in case.
McAuliffe, live from the Challenger. Teachers are excited about this.
Alka-Seltzer in the container.
Look at that bubble!
Here's your reaction.
The whole country was invested in that mission. We're going to have the opportunity to kind of bring that mission full circle. Hi there. My name is Ricky Arnold, and I'm living and working on the International Space Station. Today, we're going to look at effervescence in space. Effervescence is the release of gas bubbles in a liquid. Think about when you open a bottle of soda and bubbles come up. That's carbon dioxide gas leaving the soda. So are you ready to learn more about effervescence? Come on, let's check it out. For our demonstration today, I'm going to use an antacid tablet and water. Antacid is a tablet used to treat indigestion. If you look at the ingredients for an antacid, you'll find it contains citric acid and sodium bicarbonate, or just plain old baking soda. When acids and bases come in contact with each other, they create a chemical reaction. However, in an antacid tablet, the 2 chemicals are in solid form, and they can't react because the molecules don't move. When you drop the tablet in water, the acid and baking soda react to form carbon dioxide bubbles. And remember, bubbles are evidence of a chemical reaction occurring. How quickly these bubbles form indicates how fast the reaction is proceeding. We call that the reaction rate. Look at the two reactions, one with a full tablet and one with a half tablet. Take note of the amount of bubbles and the size of the bubbles. So pay attention to the number of bubbles and the reaction rate. And see if you notice any difference. So the next thing we want to do is to see what happens when we shake up a tablet when it's put in water. I know you're going to be using clear plastic containers in your classroom. We don't have those on orbit. We don't have very many of them. Most of them are very small. Glass we don't like because if it breaks, it floats everywhere. And plastic is heavy to launch to space. So we carry almost all of our stuff, including our food and drinks, in foil or Ziploc bags. So I'm going to try this in a little Ziploc bag, and I will shake the bag up with water in it, and I'll seal it up and see what happens. My guess is the seal is going to open as the volume of the gas starts to expand. But I'll put a little bit of water in, and then I'll throw a tablet in, and we'll see what happens. So you see the reaction. And now I'm going to shake it. And you see how fast it's forming bubbles. And then I'll shake it again. Some of the bubbles are starting to force their way out. And you can see the bag is actually inflating. And as predicted, the zipper came open and the bubbles are coming out. So that's what happens with shaking when more of the acid and the sodium bicarbonate come in contact with water, thereby increasing the reaction rate. And you could see the bubbles starting to form more rapidly. They're still going strong. If you haven't already done so, you'll be doing the same experiment in your classroom. As you do it on Earth, compare the reaction to what it looks like here in space. Talk about that with your classmates and see what they think. Thanks for participating in our experiment today. I'll see you next time.
As he just kind of floats off. I was privileged to meet Ricky Arnold several years ago at the launch for 134, and he talked about how that at 40 years of age, he was 40 years old in the classroom still working whenever he was finally accepted into the NASA astronaut program. Lisa, in reference to your question in terms of correlating to the NASA Ocean World, I'm not sure what that activity is about. If it's relating to effervescence, yes. Otherwise, I'm not sure how the volcanic bubbles connect. So, but the in-class experiment, and you can have your students do it as a class, in pairs, small groups. I would definitely have them do it more than one student. Awesome. That's great to hear, Aubrey. But have the students make a prediction before they ever start. And then you'll want to replicate the experiment in the classroom. And again, pairs or small groups. You can have a recorder, a conductor, an overseer. You can even have one person that is the videographer. I love having students video, because when students, especially a student that has to video, you tend to get that student who may not necessarily be as excited about the science side of things, but loves to be in that techie kind of, let me be a videographer, let me play with the gadgets. And then what they do is they make sure that, they use the slow-mo, or that the video is just perfect. And then you can take those videos that the students make, and while it may just be, a 10-second video, 30-second video per group, if you end up with 15 groups, you've almost got a 7-8 minute video that you could put on a loop to play back during science fairs or parent-teacher conference day, or if the school board has a visit or the school has an open house. I love utilizing lab videos for that purpose. And then the students get excited about wanting to bring their parents in to see the results of their labs, because they'll be seeing the videos while they visit. So the data table, again, you've got 4 different ones, 2 that are covered, 2 that are uncovered, 2 that are full-size tablets, and 2 that are half-size tablets. You record the time, and then the amount of bubbles compared to microgravity, and the amount of bubbles compared to other jars. So obviously they would need to see Ricky's video prior to doing the activity. So the actual experiment, you'll drop the whole antacid into an uncovered jar, start the timer, keep track until the total tablet is dissolved. Notice the amount of videos being produced. How does that compare with what's on the space station? And then record the observations. You'll repeat that process for the half tablet. Does it take more or less time, more or less bubbles? And then with the sealable lid, you're basically going to do the exact same thing, only you're going to seal the lid tightly. And they're going to shake the container, much like Ricky did. And then, again, make those observations. And so these prediction and observation skills are excellent for training students to be truly scientists and to investigate what's going on. They'll repeat the process for the half tablet. And as much as your materials allow them to compare test results. The more times they do it, the more experiments you have, the larger the size of N. And then elaborate about effervescence, acids, and bases. And this obviously, if you're, depending on the level of class that you have, if it's a high school class, and you talk about acids and base, this is really great for use within physical science or chemistry classes. If you're talking lower level students, this might be a bit much to elaborate on, but allow them some definition and review time. Talk a little bit about antacid. Heartburn is the acid caused by your stomach. And whenever you take an antacid, that base neutralizes, making you feel better. And so those are some things to kind of consider. Final wrap-up questions. There's 4 or 5 there that you can kind of go along with. And then there's also extensions for enrichment so that they can do the tablet and try it in oil or soda or different types of liquid. And so that there's different types of effervescence effects in other liquids. The other thing is you can try different types of tablets. We tried an antacid tablet. My dad has dentures, and so he's got a denture tablet that cleans every night. And the bubble rate on his tablets to clean his dentures is definitely different than that of an Alka-Seltzer, just saying. So as I mentioned earlier, and somebody else said, one of the ways that truly the life of Christa and the other members of the Challenger crew live on is through the development of Challenger Centers. They are STEM engaging organizations that reach 250,000 students annually. Oh, absolutely, Lisa. In any aspect that you can make towards that direction would be great. But as part of the Challenger Centers, they develop STEM education programs, subject and inspire students to pursue careers. It was created in 1986 by the families of the crew lost on the Space Shuttle Challenger program. And in their 35 years of inspiration, they have reached over 5.5 million students. Their core impact is career awareness, STEM engagement, self-efficacy, and 21st century skills. A lot of these, in my opinion, align with what we are expected to do within the classroom. And so there is a video here about the Challenger Center, and we're going to view that. It'll give us a little peek into what they do on or within the Challenger Center. And I have put the link in the chat box if there are video issues.
The crew of the Space Shuttle Challenger was dedicated to a mission inspired by education. Though these heroes were tragically lost, their mission would not be forgotten. The families of the crew created Challenger Center for Space Science Education, a way to honor their loved ones while keeping the educational mission alive.
When the kids are here, they realize that science is not something that's scary, and it's not just from a textbook, and this just reinforces the hands-on science that we do in the classroom, and the kids leave very enthusiastic and just loving science.
Challenger Center launches students into space every day, inspiring and engaging them in science, technology, engineering, and math.
This is Space Fact. We conduct a spectrum analysis of unknown objects.
The Challenger Learning Center does indeed make learning fun. It makes me feel kind of proud about myself because I can go back to school and I can share what I learned and show it.
When the students walk through the door of any one of the global centers, they are transformed.
We are starting the landing simulation.
Astronauts, engineers, researchers, and journalists begin working together in mission control and the orbiting space station.
There could be someone in my classroom that could find a cure for cancer someday. I think it's real important for them to understand there are jobs out there that they are quite capable of doing, and some of them were real apprehensive to come in here with everything that they see around them, but to sit and be successful was absolutely fantastic to see.
No, back over.
While students share the thrill of discovery, the simulated environment brings classroom lessons to life and teaches important skills like teamwork and communication.
It would be fair to say learning is fun here because the instructors make it fun and you will have that feeling inside of you that tells you, okay, I've accomplished this, I'm glad that I listened, and you can tell yourself that I can do it.
We reach you over.
It's all about innovation. To be able to spend a day being an astronaut or to work in mission control, my dream is that every child can come to the Challenger Learning Center at least once in their lives, and better still, many times.
As a leader in STEM education, Challenger Center's truly unique hands-on learning opportunities leave students with newfound excitement and passion to learn.
I do want to learn more about it. We went up in space and everyone communicated to each other.
Mission Controller, we are looking forward to working with you on today's mission.
Astronauts, are you ready to go?
Yeah.
Great successes start with something that happened in their youth and their childhood, and this is a fantastic experience for all of my students.
Every job involves teamwork somehow to get a job done.
It's this impact and experience that inspires students to pursue careers in these important fields and command their own destinies.
The Challenger Center experience is dynamic and unparalleled to anything else offered to students.
I think the Challenger Learning Center is phenomenal, exciting, amazing, fantastic.
It was an out-of-this-world experience.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1, end of test. Roger.
Yeah, so just several different ways that you could join in. There's other videos about classroom adventures. I'm not going to share about that today. I will share about Destination Mars in a second. So I know that somebody said that they were looking for ways to volunteer. That's just a matter of talking with the Challenger Center and see what the options are. Whenever you say, well, where are the Challenger Centers located? I'm so glad you asked that question because I just happen to have a slide for that. So the first one was opened in 1988 in Houston, Texas. But since then, there have been locations all across the country. They also have one in South Korea and in Toronto, Canada. They've partnered with community colleges in Pennsylvania and Michigan that are set to open centers in late 21 and early 22. And there's actually a location on their website where you can find out where they're located at. And as with most people, and the recent, where the one is in New, beyond this map, I did just post the link there, the one there in New Mexico. I posted the link there to the website where you can find out more information. But the other thing is that if you don't have, if they're not close to you, they have added other programs. So there's center missions, which are designed for 5 to 8 years old, and that's where you actually come to the Challenger Center for that. There's classroom adventures, which your students can do on their computer in your classroom. Those are designed for ages 3 to 5, and they They are delivered with students in the same location, and those are types of got, I think, 1 hour components where there's simulation, engineering activity, and then also science writing. And then the other one is called a virtual mission. It's a space theme, it's web-based, and it's delivered virtually. So even if you don't live near a Challenger Learning Center, there are ways that you can still be involved and bring that to your classroom. Like I said, there was a classroom adventure video. For the sake of time, I'm not going to show you that. I am going to show you the promo on the Destination Mars for the virtual mission. They actually have 2 virtual missions. One is a Destination Mars, which I'm going to show you a 1-minute promo on. And then they also have one that's Destination Moon. Here's the promo on Destination Mars. And it's a virtual mission.
Your primary goal today is to help us identify which moon offers the best possible location for our human habitat.
And the person there that was talking about those virtual missions is Dottie Metcalf Lindenberg. And she is actually another one of NASA's teacher educators. Again, there's another video about Destination Moon, but since we've only got 12 minutes left, I want to show you a few other things. If you're interested in the virtual missions, there is a web page that you can sign up to get more information. Again, you'll be able to, Vicki, it's because part of the opportunity was to decide which moon of Mars to land upon, whereas if they were going directly to Mars, they wouldn't have to decide which Mars to land on. There only is one. So it's part of that is so that you have options. Other ways that you can connect with the Challenger Center, and again, that's just a slide with all of their social media ways to connect. I have added a slide on each of the members from the Challenger excuse me, Challenger mission, so that if you wanted to know a little bit of information about them, that that has already been done for you. And again, I understand, maybe not talking about teacher, this within the classroom with your students about folks that didn't survive. That might not necessarily be, but to me as an educator, it was like when I saw this, it was like, I want that. I want to, this is something I would want to know for my own benefit. And then the other thing that I'll say, because NASA has a day of remembrance every year, and while, Challenger is obviously in my mind who I think of, they also honor Apollo 1, which is astronauts Gus Grissom, Ed White, and Roger Chaffee. That was a disaster that occurred on the launch pad. And then also STS-107, Space Shuttle Columbia. And they even have a Columbia Learning Center out in near Pasadena, California. So part of what the Challenger Center did was they actually decided not to just do it for the Challenger astronauts, but also to honor the memories of Apollo 1 and also Columbia. So ultimately, Barbara Morgan was Christa's backup. They ended up canceling the Teacher in Space program. So Barbara never flew as a part of that program, but Barbara chose to go and pursue more education and applied to the astronaut project on her own. And she flew not as an educator astronaut, but she flew as a mission specialist, meaning she was a full-fledged astronaut, and she went through the 2-year training, and that she flew as a mission specialist. Now, the difference was when she flew as a mission specialist on the STS-118, she was an educator that was flying, but she flew as the first astronaut to be a former classroom teacher. She did not fly as a teacher astronaut. The educator astronaut program, which followed up, it was created in 1998, and the call went out from NASA in January in 2003 for educators to sign up that were interested as a part of that. And so this program was created 8 years after the Teacher in Space program finished. And the objective was to seek to elevate teaching as a profession and inspire students. But unlike the Teacher in Space program, educator astronauts were fully trained astronauts who did the same jobs and duties as other astronauts. They flew as full-fledged crew members with critical mission capabilities and responsibilities, as well as having education-related goals. In addition to their technical assignments, they assisted other astronauts in connecting to students and teachers through the space program. The first class of astronauts that had educator astronauts was the astronaut class of 2004, and there were 3 candidates that were educator astronauts. That was Joe Acaba, Dottie Metcalf-Lindenberg, and Ricky Arnold. And the really cool part is that Joe and Ricky were the 2 that were responsible for being on board the space station and doing Christa's lessons. And then we also heard from Dottie whenever we were looking at the Mission to Mars virtual activity, because Dottie works a lot with the Challenger learning centers. So do not see NASA newest program. I don't know what the newest program you're referring to there is. But the 3 educator astronauts, this is where NASA opened the door to professional educators to apply to the astronaut corps. Teachers from elementary, middle, and high school fill those applications, and these 3 were those educators that they trained the duties to perform. Now, Dottie has since retired, or Dorothy, but Joe and Ricky are both current members of the astronaut corps and continue to continue with that program. Teachers in Space, so Ricky and Joe were a part of that from the 2017-2018 school year. If you've not signed up for NASA Express, I highly recommend doing that. And I want to close today with a video called Why Do We Explore? Let's watch this video, Why Do We Explore?
Roger the pitch. 7, 6, 5. Roger, roger. You're looking good. 3, 2, 1.
We are the explorers. We have a need to find what is out there. It is a drive inside each and every one of us. The drive to wonder, to push the boundaries, and to explore. We expanded across our lands, settling new frontiers. We took to the oceans and learned that we could cross treacherous expanses in the pursuit of discovery. And then we took to the skies and flew. But that wasn't enough. We left the planet and redefined what was possible. We flew in space. We walked in space. What once was a melodramatic flight of fantasy became reality. Then, a new generation of spaceships captured hearts and minds for 3 decades and helped build a castle in the sky that is our lasting home in space. We have always looked up. For centuries, we wondered what was on the other side of the sky, and we have begun to answer that question. We have learned that all the exploration humankind has achieved is only a beginning. Right now, men and women are working on the next steps to go farther than we have ever gone before. New vessels will carry us, and new destinations await us. Everything we have ever accomplished leads to this moment in time, where exploration will now take us to the planets and the stars. Our nearest neighbors in the night sky have beckoned us, invited us, dared us to reach for them. We are the explorers. Throughout our history, we have taken both small steps and giant leaps in that pursuit. Our next destination awaits. We don't know what new discoveries lie ahead, but this is the very reason we must go.